Hello and welcome to another video. In this video, we will see a few examples based on the Mason's gain formula which we discussed in the previous video. By using the Mason's gain formula, we can find the transfer function of each signal flow graph. So for this, we will see this first example where we consider an input R of S, output C of S. First, we need to calculate the forward path gain. Here there is one forward path and from the input R of S and the output C of S. And the gain of that forward path is G1 into G2 into G3 to G4 into G5. So for simplicity, I'm omitting the S terms. So here this forward path is this. And the loops are G2 H1, G4 H2, G7 H4, and this entire loop G1, G2, G4, G5, G6, G7. So there are four loops here. The next thing that we need to consider is the non-touching loops. Here there are three combinations of non-touching loops: loop 1 and 2, loop 1 and 3, loop 2 and 3. So loop 1 and 2, loop 1 and 3, and loop 2 and 3. So the gains after multiplication will be G2H1 into G4H2, G2H1 into G7H4, G4H2 and G7H4. So these are the gains of two non-touching loops. Non-touching loops taken two at a time. Next we have to take the non-touching loops considering three loops at a time. So taking three at a time. So here loop 1, 2, 3 are not touching. So the corresponding gains are multiplied. So we get G2H1, G4H2 and G7H4. Now there are no non-touching loops taken 4 at a time. So we will proceed to calculate the and delta K. So to calculate delta, we use this formula 1 minus summation of the loop gains plus summation of non-touching loops taken 2 at a time plus summation of non-touching loop gains taken 3 at a time. After substituting, we get 1 minus G2H1 plus G4H2 plus G7H4 plus G2 into G3 into G4, G5, G6, G7 and G8. So these are the loop gains plus G2H1, G4H2, G2H1, G7H4 plus G4H2, G7H4. These are the summation of the loop gains of non-touching loops taken two at a time. And finally, minus G2H1, G4H2, G7H4. These are these non-touching loop gains taken three at a time. Next, we will calculate the delta K. So delta K is obtained by eliminating from delta the loop gains that touch the kth forward path. Here we have only one forward path. So delta 1, we have to calculate only delta 1. So that is calculated by 1 minus G7H4. So G7H4 is the only loop that doesn't touch this forward path. Delta 1 will be 1 minus G7H4. Now we will calculate using Mason's gain formula. We will calculate the transfer function. G of S is equal to T1 delta 1 divided by delta. So T1 is a forward path gain. So G1, G2, G3, G4, G5, that is T1, and 1 minus G7, that is delta 1, and the delta which we have taken earlier. So that gives you the transfer function. So we just have to apply the Mason's gain formula to simplify that entire network and get a single transfer function between the input and the output. We will consider another example. So in this example, we have two forward paths. The first path is from input to the output is this one, and the gain of that forward path is 1 multiplied by 1 by s multiplied by 1 by s multiplied by 3. The next forward path is this one, and the gain is 1 multiplied by 1 by s multiplied by 1. So there are two forward paths here, and there are two loops here. Loop 1 is the smaller loop, 1 by s multiplied by minus 10, and the second loop is this one. So that is 1 by s multiplied by 1 by s multiplied by minus 24. So those are the two loop gains. Now there are no non-touching loops taken two at a time here. So there are only two loops and those two loops are touching. So there are no non-touching loops taken two at a time. So we can go directly to the calculation of delta and delta k. So here delta is calculated as 1 minus summation of loop gains plus summation of non-touching loop gains is avoided because there are no non-touching loops here. So substituting the loop gains 1 minus 1 by s multiplied by minus 10 plus 1 by s square multiplied by minus 24. So this is delta. K is calculated by eliminating from delta the loop gains that touch the kth forward path. Here there are two forward paths. The first path is this and the second path is this. In both cases, the loops touch both the forward paths. So we have delta 1 equal to 1 and delta 2 equal to 1. So here the transfer function using the Mason's gain formula will be T1 delta 1 plus T2 delta 2 divided by delta. Substituting all the values which you have found just now, you will get 1 by s plus 3 by s square divided by 1 plus 10 by s plus 24 by s square. Multiplying numerator and denominator with s square, we get s plus 3 divided by s square plus 10s plus 24. This is the transfer function of this signal flow graph. Now we will see another example. Here we have two paths. The first one is path here and the second one is the path here. So from the input to the output, we have two forward paths. And the gain of the first forward path is 1 by 2 minus 1 by 2 multiplied by 1 by s multiplied by 1. And the gain of the second forward path is 3 by 2 multiplied with 1 by s multiplied with 1. So we get minus 1 by 2s and 3 by 2s. And there are two loops here. The first loop is this one. The gain of that loop is minus 4 by s. Second loop is this one, and the gain of that loop is minus 6 by s. Next, we have to calculate the non-touching loops. Here the non-touching loops are 2, and the gains multiplied of value minus 4 by s multiplied by minus 6 by s. And to calculate delta, we use the formula 1 minus summation of the loop gains plus summation of the non-touching loops taken two at a time. Here we have only two loops. This will be equal to 1 minus 4 by s plus minus 6 by s plus minus 4 by s multiplied to minus 6 by s. So that will give you 1 plus 10 by s plus 24 by s square. Next, we will calculate the delta k. So that is obtained by eliminating from delta the loop gains that touch the kth forward path. So here we have two forward paths, and the gains that is not touching that forward path are minus 6 by s and minus 4 by s for loops 1 and 2 respectively. So we will substitute that formula and we'll get that delta 1 value as 1 plus 6 by s and delta 2 value as 1 plus 4 by s. So now we are ready to calculate the transfer function using Mason's gain formula. So by formula we'll get T1 delta 1 plus T2 delta 2 since we have two forward divided by delta. After substituting the values which we have just found, and after simplification we will get the transfer function as s plus 3 divided by s square plus 10s plus 24. Now we will see another example. In this example, from the input R of s to output C of s, we have two forward paths. The first forward path is this, and the second forward path is this. Now the gains of that forward paths are T1 equal to 1 by s into 1 by s into 3, and T2 equal to 1 by s into 1. Two loops here. So this is the first loop and this is the second loop. And the loop gains are minus 4 into 1 by s and minus 6 into 1 by s. And these two loops are non-touching loops. So there is no common node between them. So non-touching loop gains taken two at a time will be minus 4 by s into minus 6 by s, that is equal to minus 24 by s square. There are no non-touching loops taken three at a time. There are only two loops here. So we are now ready to calculate the delta and delta k values. So delta value is equal to 1 minus summation of the loop gains plus summation of the non-touching loop gains taken two at a time So after substituting that, we will get 1 plus 10 by s plus 24 by s square. And delta 1 is nothing but when taken the first forward path, both the loops touch this forward path. Hence, the value of delta 1 will be 1. Similarly, when you take the second forward path, both the loops touch the second forward path. Hence, the value of delta 2 will be 1. So now we are ready to find the transfer function. So by Mason's-Gaines formula, the transfer function will be T1 delta 1 plus T2 delta 2 divided by delta. Here we have two forward paths. So T1 delta 1 plus T2 delta 2 divided by delta. Substituting that values, we will get, and after simplification, we will get s plus 3 divided by s square plus 10s plus 24. Now you may have noticed that the previous three examples we have discussed, the transfer function is the same thing. So the transfer function is s plus 3 divided by s square plus 10s plus 24. So this shows that the signal flow graph can be different, but the transfer function can be the same. So the relation between the input and output can flow through different path, but the transfer function can be the same. So we will discuss more topics in the next videos. Thank you.